Hello, and today's purpose of the day is I can write a linear equation from a word problem and graph it. I can also determine slope from a graph. Let's get started. Okay, for this example, we are going to write an equation and graph the points to represent this equation. So let's read problem number 1. Rachel receives a base salary of $50,000 and a commission of 15% of the total sales for the year. Part A. Write a linear model that shows Rachel's total income based on total sales of X amount of dollars. So let's look here with our equation. We have that she earns a base salary of $50,000, so that's what she receives no matter what. Then she receives a commission of 15% of the total sales. So that means of the total amount of sales that she sells, she earns 15% of that. So for a linear model, I'm going to write y equals, now she earns 15% of the total sales of the year. So if I change 15% to a decimal, I move that decimal 2 places to the left and drop the percent sign. So that's 0.15 times x of how much, her total sales are. We don't know what they are going to be, but she'll make 15% of that. Plus, she earns $50,000 no matter what because that's her base salary. Okay, part B. If Rachel sells $315,000 worth of merchandise, what is her total income? So now 315 is the number that I want to plug in for X and figure out what or how much money she will make for that year. So I'm going to plug in 315,000 in for X in my equation and then add 50,000. So then in my calculator, I would type this exactly as I see it, 0.15 times, in parentheses, 315,000, close parenthesis, plus 50,000, and Rachel earns a total amount of money of $97,250 if she were to have $315,000 worth of merchandise or commission sales. All right, now part 3. Graph the change in income. So on my graph, I've already labeled the X and Y axis and a title. So the title is Rachel's income or sales, and on the Y axis, I have total income in thousands of dollars, and on the X axis, total sales in thousands of dollars. So I'm going to go ahead and scale my graph so that it can appropriately fit on this graph. Now, I've chosen to scale my x-axis by 50 because I want to make sure I can graph that Rachel has made sales of $315,000. Then I also scaled on my y-axis by 20s. Now, I maybe necessarily didn't even need to scale by 20s because her total income, really, if she sells $315,000 merchandise, was less than, a little bit less than $100,000. So I want to make sure I can account for that there in my graph. Now I'm going to pick values to plug into my equation so that my graph can appropriately, or my line of my graph can appropriately be graphed on this graph right here. Now I know that if I plug in 0 for x into my equation right here, that if I plug in 0 right there for x, I'll just get 50,000 because anything times 0 is 0 plus 50,000 will just be 50,000. Then I also already solved for that if I plug in 315,000 for X, so if that was her sales, what is her salary? Well, her salary then, or her income, was 97,250. So I've already got those 2 points plotted, but let's just find one more just in case. Let's plug in, maybe if she makes $150,000 in total sales. So now this will be Y equals 0.15 times 150,000 plus 50,000. Now we'll grab our calculator and let's figure out what this output will be. This output, or her income then, will be 72,500. So I'm going to graph these 3 points on my graph right now. So if I go over here, I'm going to graph 0, 50. So 0 and then about 50 would be right there. Okay, then I'm also going to graph 150 is what I plugged in for X, and again, this is the X-axis, this is the Y-axis. I'm going to, plug in 150 for X, and then my output was 72,500, which we just did together. So 150, about 72,000, would be about, about right there. And then the last one that we did was 315, and we got an output of 97,000, so about right there. And then we'll connect those and make a straight line as your graph should be, because again, these are linear equations. And now we are done with this problem. All right, problem number 2. The population of Rosemont is 25,000 people today. Every year, the population of Rosemont increases by 100 people. Part A, write a linear model that represents the population of Rosemont X years from today. So if I wanted to write an equation to represent that Rosemont is growing by 100 people a day, or 100 people a year, and has 25,000 people already, that will be y equals 100 times however many years that we'll have, plus the original 25,000 people that are already in Rosemont. So that's part A. Part B, in approximately how many years will the population of Rosemont exceed 60 people? Well, that's our output. When will it get to 60? So I need to plug in 60,000 for y. So 60,000 for y equals 100 times however many years it will take plus 25,000. So if I solve this equation, I would need to subtract 25,000 on this side because I want to isolate x. And I get, bring this down right there to 100x equals 60,000 minus 25,000 is 35,000. And last but not least, to isolate x, divide by 100. 35,000 divided by 100 is 350 years, is how long it would take if we wanted the population to get to be 60,000. Now, that's just assuming that there's only, or each year, Rosemont only increases by 100 people. But we know that already Rosemont probably has more than 25,000 people and is growing right now by more than 100 people a day. But if this was what were really happening, it again would take 350 years to get to a population of 60,000. Let's now look at part C, graph the change in population. So as you look at my graph right now, I've already labeled a title, Rosemont's population. I've labeled the x-axis. Again, that's right here as the number of years, and the y-axis as in the number of people in thousands that are in Rosemont. So right now, we want to figure out how to graph this and scale it. So let's take a look at a couple values we could plug in for x. Well, we know if we plug in 0, at 0 years, how many people are already in Rosemont? Well, that would be like, for example, this year. If I plug in 0 for my equation in for x right there, 0 times anything is 0 plus 25,000 is 25,000. So we know the point 0, 25,000 is on the graph. But let's perhaps plug in a few more values after we scale our graph. And I'll go scale my graph right now. Okay, so I've scaled my graph on the x-axis just by ones, so number of years after this year. And I've scaled on the y-axis just by tens, so really represents 10,000s. And so we know the point 0, 25,000 is on the graph, so I'll go ahead and plot that right now. So 0, 25,000 would be about right there. Okay, now let's plug in another value. So maybe let's plug in like after 3 years, what would be the population? So here I will say y equals 100 times 3 plus 25,000. I'm going to go ahead and plug this into my calculator. And I get, when I plug that in, 25,300. So again, we're only growing by 100 people a day, so it's not going to look like it's a huge steady jump up in population, or 100 people a year. It's not going to look like it's a huge difference. So after 3 years, still a little bit over 25,000. Right? Now let's just try like 8 years. The last number I have on my graph. So let's say y equals 100 times 8 plus 25,000, and that will be 25,800. So again, it's not a super huge jump, but let's go ahead and graph that. And again, that's going to look like about right there. And I'll draw a line to go straight through these points as best I can. And this would represent the population of Rosemont if it were growing at 100 people a year and began at 25,000. Let's talk a little bit about slope. You can find slope of a graph by finding the rise over run. And we'll talk about what that means in a moment. You'll see the equation y equals mx plus b come up a lot in your math class. And here with this equation, m is represented by slope. This again is the number that is in front of the variable x. So there are 4 different versions that we can have of slope. The first one right here is we can see a positive slope. So this means that we have a straight line that goes from left to right and is increasing. Or we could see a negative slope that is opposite of positive. This line is decreasing from left to right and is going in a downward motion. We could also see a slope of 0, and that means our line is just flat. It's not going up, it's not going down, it's just a horizontal flat line. And last but not least, we could also see an undefined slope. An undefined is a straight up and down line, vertical line, that would be too much to calculate, so we have an undefined slope. Let's practice a little bit about finding the slope of a line. So let's look at this first example. I have 2 points that are already plotted on this line. So I'm going to start at one of the 2 points. I'm going to start at the one on the left, this one at 0, 0, right here. Now I'm going to figure out the rise over run that it takes to get to the next point, and that will be the slope of this line. So how much do I rise up or rise down? Well, to get from this dot, this point, to this point, that other dot, I need to rise up 1, right? Go up 1 unit, then I'm in line with the next ordered pair or point. So that would be a rise of 1. Now what's the run? So running either left or right would be 1, 2. So that run would be 2, which means this line would have a slope of 1/2. That line is increasing at a positive rate of 1/2. Let's try the second example and calculate the rise over run again. So again, rise over run. Now I can already tell with this line that it will be a negative slope because it's decreasing from left to right. But I'm going to start at the top ordered pair here, and I have to rise till I get to the next point, which really means I have to rise downward because the next point is below this point. So I'm going to go down 1, 2 units. So that will be -2 for the rise. Now I'm going to run to the right, to the right, and that's a positive direction. Left would be to the negative direction. So 1, 2. So -2/2. Now this is a fraction that we want to look at simplifying. If it were to be an improper fraction, that's okay. We would still want to simplify it, but never change a fraction to a mixed number. Don't ever with slope. So here if I simplify, -2/2, I could take a 2 out of both, and I have -1/1. So m equals, and again m represents slope, -1, and you could say over 1 if you wanted, but you certainly don't have to. Okay, number 3, now I can definitely tell with this one that it's going to be a positive slope. So let's start with this, lower point, and I'm going to rise up 1 unit. Now I'm going to run 1, 2 units. So this slope is 1/2. Okay, and last one we'll go over is number 4. So this again will be a negative slope, and I can tell because it's going decreasing from left to right. So I'll start at the top point. And I could again start at the bottom point. I'll get the same slope, but I'm just going to start with the top point and rise down 1, 2, 3, 4, 5. So -5 over 1, 2, 3, 4. Now, this is again an improper fraction, but I'm not going to change it to a mixed number. I'm going to leave it as an improper fraction, and we'll talk later about why that's more appropriate. But for right now, we're just going to leave it as an improper fraction, and there's no simplifying because nothing goes into 5 or 4, so my slope would be -5/4. Thanks for watching. Have a great day. Please check Google Classroom for more information. Bye-bye.